Hello, hello. This is the final video on complex numbers, okay? And this time we are going to be dividing our complex numbers. All right, let's begin. So when we divide an imaginary number, it or when we divide by an imaginary number, meaning an imaginary number is in the numerator, right? So we need to simplify that further. Okay, so we need to not have an imaginary number in the denominator. Okay, and then the only time that we can do that is by multiplying by another imaginary number, right? Because when you multiply the denominator, an imaginary number, by another imaginary number, now you have I to the power of 2, which becomes a real number. Okay, so that's a trick that we are going to use. So we're going to multiply the numerator by an imaginary number I, and then the denominator also by an imaginary I. So what that becomes is 3 times I, which is 3I. It's okay to have an imaginary number in the numerator. And let me clarify, right? So it's not okay to have a imaginary number in the denominator, right? So now, but 2I times I becomes a real number now, right? Because I squared is, this becomes 2I squared, and I squared is real. And so what this is going to end up being a negative 2 in the denominator. So altogether you have negative 3I over 2. Okay, so a 3 divided by 2I will end up being and simplifying as negative 3I over 2. Okay, so that is the simplest explanation I can give. Okay, so which is also written as negative 3 halves I, or negative 3I over 2 is both correct. Okay. All right, so let's take a look at some examples here, right? So we have two examples. It says 7 divided by 6I, right? So a trick to that again is by multiplying by I so that the denominator becomes real, right? So now that becomes 6I squared, and now the top becomes 7I. So this is a real number, negative 1. So that becomes negative 6. So this is negative 7 over 6I, or you can write it as negative 7I over 6. Either way is okay. Okay? All right, why don't you try this one and see if this is going to be easy for you. All right, so pause this video and see if you can handle this. Okay, so let's unpause and then see if we truly understand. So we need to multiply the numerator and denominator by I so that the denominator is a real number. So that becomes I squared, okay, which is real. And then this becomes the need to distribute. So this is a group. 5 distributes to I, which is 5I, and then 4 distributes to I as well, which becomes positive 4I squared. Right, so we've got this is a real number and this is also a real number. So let's simplify those. 4I squared simplifies as negative 1. All right, so that has to go in front of the imaginary number. So this becomes negative 1 plus 5I, and then this becomes a negative 1. Now, when you divide by negative, your sign changes. So that's going to become a positive 1 and then a negative 5I. So this is the final answer. Okay? All right, so I hope that makes sense. So 4 minus 5I, we got the same thing. Oh, we did not get the same thing. That is my fault. This is not negative 1, this is negative 4, right? And that's positive 4 because this is being multiplied by 4. Sorry. Okay, so let's see. All right, so that's 4 minus 5I, and we got the same thing now, 4 minus 5I. Okay, so now the problem goes as far as the following. Sometimes you're not always just going to have one imaginary term in the denominator. Sometimes you'll have a denominator that's a complex number. So which means the trick to that is to look for a conjugate. Okay, so a conjugate is a pair of binomials that has a product that's equal to the difference of squares. So which means if you have an x plus y, the conjugate is x minus y. Okay, when you multiply these two, it'll simplify to something like this. So imagine that that would be an I, right? So when you multiply those two together, then you'll have two real numbers resulting into a real number altogether. So let's say, for example, um, 3 plus 2i and 3 minus 2i, right? So these are conjugates, right? It's the same binomial, same terms, but one is a plus and one is a minus. And you'll notice that every single time you FOIL out conjugates, it ends up being a real number because 3 times 3 is 9, okay? And then this is going to end up being a negative 6i, and the middle term will end up canceling out with the previous term, and then the last term will end up being a real number because that's going to end up being a negative 4i squared, okay? The point I'm making is if when these two cancel out, you're left with a real number. So you're left with 9 plus 4, which is equivalent to 13, all right, which is a real number. So when you have a denominator that is not just an imaginary number, but more of a complex number, right? You need to multiply by its complex conjugate so that the denominator becomes a real number. Okay, so for example, if you have 3 plus I in the numerator and a 1 minus 2i in the denominator, you can't just multiply by I and then have these two become a real number. That's not going to work because it's not going to be a real number. Okay, so a fix to that is to multiply each one by its complex conjugate, right? The denominator is complex conjugate. So you're looking at 1 minus 2i. The denominator that would make it into a complex conjugate is 1 plus 2i. What you do at the bottom, you also do the same thing at the top. Okay, so now what happens is when we multiply this group and this group together, the middle imaginary terms cancel out and you're left with two real numbers. So you're left with 1 times 1, which is 1. And then you're left with, I don't really need to write it out, but these two will cancel out. So 1 times 2i is 2y, and then negative 2i times 1 is negative 2i. So they'll cancel out. So I don't need to really explain that. So negative 2i times positive 2i is going to end up being negative 4i squared. Okay, and then together, really what that becomes 1 plus 4 because this is negative 1 and this is multiplied by negative 4 becomes positive 4. And now by multiplying by its complex conjugate, the denominator is now not a complex number, it is now a real number. Okay, so that's how you would work it out. Okay, now let's do the numerator. So in the numerator, we would multiply 3 times 1, which is 3. And then 3 times 2i, which is positive 6i, and then 1 times i, which is positive 1i, and then we would multiply I times 2i, which is positive 2i squared. All right, and we want to recognize the real numbers first. So this really becomes negative 2. And then so this becomes 3 minus 2. Okay, so 3 minus 2 is positive 1. Okay, and now we combine our imaginary together. So that's 6i plus I is positive 7i. So altogether, our final answer is 1 plus 7i over 5. So this is equal to this. Let me highlight it. This mess is equal to this, whereas this has a complex number in the denominator, which it can't, and this one has a real number in the denominator. Okay? All right, so I hope you understand that because here it comes. Let's try and simplify this equation. So pause the video and see if you could do this by yourself. Okay, so let's try it out. So first we have to look for its complex conjugate, right? So the complex conjugate of 1, I'm sorry, you know what? Let me work with it at the bottom here so I have enough room. So negative 1 divided by 1 minus I. Right, so I want to multiply by its complex conjugate, and its complex conjugate is 1 plus I. What you do at the bottom, you do at the top, but let's do this one first. So 1 times 1 is equivalent to 1. And again, I'm not even going to bother doing the middle because you know they're going to cancel out. And then so negative I times positive I is negative I squared. All right, and let's keep going with that thought here. So this is going to end up being a positive 1. So this is really 1 plus 1, which is positive 2. So now I know my denominator is 2. Okay, now the numerator is quite simple because I don't need to FOIL, I just need to distribute. So negative 1 times 1 is positive negative 1, and negative 1 times I is negative I. So the numerator is negative 1 minus I, and the denominator there is 2. That's your final answer. Okay? All right, let's try some more. So why don't you try this equation, this complex number, and see if you can reduce this. Okay, let's work this out. So we have 3 minus I in the numerator and then 5 plus 4I in the denominator, right? So the complex conjugate is going to be 5 minus 4I. 5 minus 4I. Okay, so that's going to be equal to, so 5 times 5 is 25, and then 4I times negative 4I is negative 16I squared. Okay, so what this is really going to be 25 plus 16, which is going to equal 41. All right, so my denominator is 41. All right, now my numerator. So 3 times 5 is 15. Let me use a different color. 3 times negative 4I is negative 12I. Negative I times 5 is negative 5I. And then finally, negative I times negative 4I is positive 4I squared. I'm running out of space. So now we're going to continue to combine our real numbers first. So this is really a negative 4. So this is 15 minus 4. And 15 minus 4 is 11. And then negative 12I minus 5I is negative 17I. So this is 11 minus 17I over 41. Okay? I hope you're getting in the hang of this. All right, last one. Pause this video and see if you could do this by yourself. Okay, let's try and work it out together. All right, so we multiplied denominator by 6 plus 2I and numerator by 6 plus 2I. And that's going to end up being 6 times 6, which is 36. And negative 2I times positive 2I is negative 4I squared. All right, this really becomes 36 plus 4, which ends up being 40. Okay? All right, so as you can tell, you're probably doing it faster and faster now. So 4 times 6 is 24. 4 times positive 2I is positive 8I. And then I times 6 is positive 6I. I put it on top because I'm running out of space. And then I times 2I is positive 2I squared, which is going to be a real number, right? So the numerator really is 24 minus 2, which is 22. And then 6I plus 8I is 14I. So altogether, this is 22 plus, all right, 22 plus 14I. Now, you're inclined to say, like, okay, this is it. This is the final thing. Well, the problem sometimes is that it also needs to be reduced. Okay, so this is all divided by 40. So these are all even numbers, so I know that they could be divided by 2, right? So 22 divided by 40 becomes 11 over 20. And then plus 14I divided by 40 becomes 7I over 20. So this is how it's written as well. Either this or two separate fractions. Okay, and then that is it. Thank you for watching.